Good day. So we're looking at our isomers PowerPoint. You might remember structural isomers from last year, but you may have forgotten them. And then geometric isomers will be something that's new. I'll probably do this in 2 videos, or maybe 3. I'll probably look at structural first, then we'll look at geometric, and then I may try to build some models to make it make a little more sense. But I'm hoping this will make a fair amount of sense from the PowerPoint. Well, ISO means the same. And so what we're looking at are molecules that have the same molecular formula but different arrangement of atoms. And that means they would have different structural formulas. They're going to end up with different names. And it says at least one bond would have to be broken to create the other structure. And of course, if we're breaking bonds, then we're going to reform bonds. So every isomer has to have a different name. And that's one way you can tell if you've done it right for the isomers. So you'll get given things that may appear different, and you've got to see how they compare. If they have the same, or if they have different molecular formulas, they're completely unrelated for this kind of question. Unfortunately, if they have the same molecular formula, then they're either identical or they're isomers. And the way to tell if they're identical is, do you end up with the same name for both of them? And if you do, they're identical. And if you end up with different names, then they are isomers. And so this is what the IUPAC land is talking about. Same IUPAC name, identical, different IUPAC names, isomers. So when I look at this one, I see I have 4 carbons, and here I have 4 carbons. And I also have 10 hydrogens here, 10 hydrogens there. So the first thing I've established is they have the same molecular formula. And I want to know then, are they identical or are they isomers? Well, if I name this thing, I would call this methylpropane. If I name this thing, I'd call it methylpropane. These guys are identical. They have the same name. They're both methylpropane. The central carbon has 1 hydrogen. Central carbon, 1 hydrogen. It's bonded to 3 CH3s. Now we look at this one. Well, when I do my formulas, I go 1, 2, 3, 4, 5. They both have 5 carbons. And then I go 5, 6, 7, 8, 9, 12 hydrogens. And I go 3, 4, 5, 6, 7, 10 hydrogens. So in one case, I have C5, H12. In the other case, I have C5, H10. And since they have different molecular formulas, then they are unrelated in this game. In fact, we know this is an alkane, and this is an alkene, and it would have quite a different name. Next one, let's get our molecular formulas, and we say, whoa, these are both C8H18. So now we have to go and name these things. So we go, there's my longest sausage, 3, 4, 5, 6 in a row, so I know it's hexane. So it's 2, 3 dimethyl hexane. Let's check this one out. Boom, there's my longest sausage. Interesting. Hexane again, 2, 3 dimethylhexane. They look different, but these in fact are absolutely identical. They have the same molecular formula and they have the same name. And these things actually can snake around and shift like this. They do have this mobility around their bonds. So that's looking at structural isomers. Oh, we got some more here. Now in this case, we got C7H16. In many ways, these are close cousins, but they are unrelated because they have different molecular formulas. And the last beast, well, we'll see if it's the last beast. When I look at this, I say, hey, they're both C5H10. If I went to name this one, oh, I see I've got 4 carbons in a row. So that's bute, and it's going to be butene. It's going to be a 1-butene. I go 1, 2, 3, so it's 3-methyl. Methyl's on the 3rd carbon, 3-methyl, 1-butene. When I look at this thing, it's just cyclopentane. Different names, these are isomers. Geometric isomers we'll do in our next video.